For our presentation, we are describing the effects of air pressure, the Magnus effect, and club contact on the slicing of a golf ball. A golf ball slice is when it curves dramatically from left to right for right-handed golfers, or right to left for left-handed golfers. This should not occur. We want the ball to either be hit straight or have a slight curve to it. We linked here a video of how an actual slice looks. As you can see here, the ball starts straight and curves off to the right for this golfer here. The actual path that we would have wanted to happen would be the ball to land somewhere in here, but since it did slice, the ball landed very right of where we wanted the ball to land, into the trees. Here is the draw, which is where we want it to land. As you can see, there's a slight curve that has a curve inward, but due to many circumstances, the ball slices and curves off to the right. One of the many circumstances that causes this to occur is due to the club angle that the club hits the ball at. If it hits it with an open face, which is an obtuse angle, the ball will slice, more than likely. When hit, a rotating ball will travel through the air and create relatively low pressure on the side of the ball that is rotating with the same direction as the airstream. If there is a high pressure, which is caused by the side of the ball rotating against the flow of the airstream, premature laminar separation occurs. This causes the ball to slice since a low pressure has a better adherence to the ball, causing it to stay on course. And as you can see here, with a closed face, it's going to open this way, curve back towards the target. And for an open face, it will curve or start this way and then curve away from the target, as we saw with the hit. If the ball is hit incorrectly, it will have a clockwise spin. This will deflect the air and the ball will go right. This is explained better by the Magnus effect. The same goes for a ball hit incorrectly with a counterclockwise spin for a lefty. It will just travel the other way, to the left. This is based upon the Magnus effect, which explains the force that is generated by a spinning object traveling through a viscous fluid, and in this case, when you're hitting a golf ball, the viscous fluid is the air. When the force pushes the air down on the ball, there's an equal and opposite force that pushes up. That can be seen here in our diagram. So if the ball has an awkward spin due to the way that was hit, the resultant force will cause the ball to slice. So the force, instead of being just down and up, traveling straight, the ball would have a force that goes either this way or that way, which causes the ball to then slice to the right or slice to the left. This can also be shown more in a video demonstration here, based on the way a basketball is spinning off of a dam. This basketball is traveling downward, so the airstream is causing it to go this way, but then another airstream is causing it to rotate this way. With an awkward spin, the ball will curve more to the right or to the left depending on how the spin is. In this case, it curved off to the left. Based on Bernoulli, a low pressure means that it's a higher chance for the ball to go straight and not slice. Bernoulli's equation is right here. Based on what was said prior, a correctly rotating ball will cause a low pressure to occur on the side of the rotating ball. This will cause it to stay straighter. In higher elevations, there will be lower air pressure, as again explained by Bernoulli, with Z1 and Z2 being the elevations and P1 and P2 being the pressures. If the air is less dense, there will be less of a lift force, but the ball will travel at a lower trajectory and a farther distance traveled. The lower trajectory leaves less of an opportunity for the ball to slice, again explained by Bernoulli. If there's lower air density, the ball will have a lower Reynolds number value. Here shows the Reynolds number equation, with the air density being one of the driving forces of the number for RE. The lower Reynolds number value, the more laminar the flow is, and the less of an opportunity for the ball to slice. The more laminar the flow is, the less laminar separation occurs, which then allows the ball to travel in a straighter path rather than to slice off to one side or the other. Based on these things, our conclusions are that the spin of the ball is not completely dependent upon the elevation or pressure or density, but also on the golfer's swing. If the golfer swings with an open face, there's a higher chance that the ball will travel either right or left, depending on if the golfer is a lefty or a righty. This is due to the Magnus effect and the rotation of the ball. At lower pressure, there is less of a chance for the ball to slice based on the correctly rotating ball, as shown through Bernoulli's equation and the Magnus effect. Our third conclusion would be that at lower density, a lower trajectory occurs, and this allows for a lower chance of the ball to slice based on Bernoulli. If there's less of a density in the air, the ball will travel a smaller and less high up trajectory, which will then in turn lead for a less likelihood of the ball slicing. At a high density of the air, the Reynolds number is higher, making the flow not laminar but turbulent, and this leaves for a higher chance for the ball to slice, and this is based off the Reynolds equation.